Okay, so we're given this problem, and essentially what we need to find is the length SD. So one piece of information that we have to use is about this right here. So points E and F are located on a horizontal line whose extension passes through the foot D of the perpendicular from the vertex S. So these guys right here are going to be perpendicular. Okay, so for the first one here, we have 90 plus 31 will make this angle 121 degrees. And if this is 90, this is 48, well, this also has to be 90. So 90 minus 48 will give us 42 degrees for the inside. Okay, the next thing we're going to do is solve for x here. And in order to do that, we need to use law of sines. But actually, before we do that, let's first find angle S. We know that this triangle adds up to 180. So we have 124 and 42, which leaves this angle as 17. So we're going to use law of sines. We're going to have x over the opposite angle, which is 121, equals, now the length here, EF, is 120. So that's 120 over sine 17. I'm going to solve for x by bringing the sine 121 to the other side. And I get 351.813 meters. Okay. All right, so keep in mind I want to solve for SD. So next I'm going to solve for SA. So this is a right triangle, perpendicular. So I know the angle, I know the hypotenuse, I can figure out the opposite side. So I'm going to use sine for that. It's going to be sine of 42 degrees is equal to the opposite, I'll call it y, over hypotenuse, which is what I just calculated. I'm going to solve for y to be 351.813 sine of 42 degrees, and that is going to be 235.409 meters. So that's SA, but I want to find SD. SD over here is 1.25 meters. So I'm going to have to take 235.409 and add 1.25 to that. So the answer will be 236.659 meters.